Okay, here's the key for the first part of it. Rewriting in log form, that formula was the base b of, base b to the x equals y means log base b, and then these guys switch places. So that's the formula. That means this is b. So we would go log base b, 4, and then switch these guys of 64 equals 3. Don't forget that E automatically means ln. Swap places. 52 now it's going to go on the left. And that equals 7y on the right. Okay, this one, 5p is the base. This whole thing is going to be the base. And that's okay that it's got a p in there. It doesn't matter. And we swap places. So this is going to be a to the 6th. But what is the power right here? Well, if there's no power written, we know that it's a 1. So we're going to say it equals 1. Now going backwards, the formula is just the reverse. Log base b of x equals y turns into a big B, switching sides. Okay, this one, again, here's the B. Swap sides. Right, this one, we've got it backwards. See, I like to write it this way, so it's easier for me to see which one's which. I almost wanted to put 2x as the base, but it's actually not 2x. It's 7. Or it's 10. Whoops, my bad. Oh, wait, let's pause and look at this for a minute. This is log base 10. Remember, there's no base on the log, that means it's a 10. So my base is 10. Swap sides. The power is the 2x, and it equals the 7. I should have compared that with the formula there to kind of remind myself what it was. Okay, here, this is 3, so I'm going to write log with a base of 3, and then these guys are going to switch. Just because there's more than one thing there, it doesn't matter. Just throw them both over there in parentheses and put it as a 14. Okay, solving the equation. Now steps look like this. First thing you have to do is you have to get the exponent alone. Our goal is to be able to switch it into logs, and that will get the x out of there. Boop, boop, boop. Calculator is going to help us find the answer. So 1, get the exponent. That's the b to the x alone by adding or subtracting, and then divide if necessary. Okay, 2 is you're going to convert to logs. 3 is to finish solving for x, which again means you might have to multiply, divide, add, subtract. Add, subtract, and multiply, or divide. It's usually divide. All right, so this first one here, here's my exponent, e to the x. So I need to be able to get rid of this guy, well, it's plus 7, so the opposite would be to subtract 7. So that gets rid of that. We have 5e to the x equals 15. Next is to get rid of that 5. So we're going to divide both sides by 5. You cannot take the log when there's a number out in front of that. So now we're at e to the x equals 3. Now we're going to convert. E automatically means ln. Swap sides. You get ln of 3 equals x. Then we plug that into our calculator and get x is approximately, we go to, let's say 1 decimal place, then x is approximately 1.1. That approximately is because I'm rounding. If you left it off, I wouldn't mark you out, wouldn't mark you wrong, but for multiple choice, it's going to be in there. Okay, here's my exponent, 4 to the x, so I've got to get rid of that 3. I'm going to add that to both sides. 4 to the x equals 14. Exponents alone, so we can convert to logs now. Log base 4, swap sides, of 14 equals x. So log base 4, 14. X is approximately log base 4. If you remember in your calculator to do that, you have to go into the math menu, go to the very bottom, capital A number, and it says log base. That lets you change that little number. If you don't change it and you just use the log key, that's actually base 10. All right, rounding to 1 decimal place, we get x is approximately 1.9. Oh, also on Desmos, if you decide to use that function, it's on the keyboard. Over to the right, it says functions, and then the miscellaneous tabs. So you've got to be able to go there if you know. Sorry, if you have to convert to, or if you have to calculate a log. Gee. Okay, this one, here's my exponent. It's a number raised to some power. That minus 1 up in the power doesn't matter yet. We have to convert now that it's got the log all by itself. So log base 3, swapping sides, of 5 equals that whole power, x minus 1. Now to finish solving, we would add 1, and we would get x equals log base 3 of 5 plus 1. Now I need to pause for a minute and remind myself that this cannot be combined with the plus 1. This log base 3 of 5 was something that was by itself, and then you'll add the 1 after. So plugging that into my calculator. Log base 3 of 5, and then I'm getting out of the parentheses and adding 1. Or you can do it in 2 steps. It's up to you. So x is approximately 2.5. Okay, solve the following exponential growth and decay problems. Growth means it's increasing, decay means it's decreasing. So our formula for these were y equals a times 1 minus plus for growth. This is growth. Or it could be the other one, y equals a times 1 minus r to the t. This would be decay. Now the variables that are in there, oops, remember that a is the initial amount. What is initial? R is the rate. Has to be, quit it. As a decimal. And then t will be time. Now there are also two specific formulas when it came to interest. This was for compounded interest, and that's the key word right there. So the basic formulas were A equals P times 1 plus R to the n, divided by n to the power n times t, or P times E to the RT, where P is the initial, R is the rate, that's a decimal, T is time, N is for this guy only, that's the number of times a year. And this guy is only when it says continuously. You've got to look for that keyword right there, because that's when you know to use this formula versus those other ones over there. So continuously for this guy. This one will say compounded, but it will have a specific number like quarterly or semi-annually. And it'll give you that kind of stuff. All right, so 10 says you deposit $4,000 in an account that pays 7% annual interest, compounded, keyword, and then the second keyword there is continuously. Continuously means my formula is going to be A equals P times E to the RT. Whoopsie, nice little bell for us. So we're going to go with our basic formulas. P is at 4,000. R is our 7%. We've got to write that as a decimal, so 0.07. And then T, they tell us to do it after 5 years. Okay, plugging it in. 4,000 is that P. Now E is just the button on your calculator. Don't forget that you don't have to plug in the E when you're actually, E is a variable, there's nothing to plug in for it, sorry. So A is going to be about, calculator says, about 5,676.27. Comment out. This computer hates me. Just kidding. They hate me. Just likes to mess with me. 5,676.27. Okay, this next one, if you read through it, it actually says collectible valued at 300. Okay, 300 is important. That's an initial amount. It has increased in value at an annual rate of 17%. Then what would it be worth in 2016? Now, it does not say the word compounded, but it does say increased. So we're going to use that growth formula. That looks like that. Right? So A was our initial amount of 300. R, it tells us, is 7%. Got to convert that to a decimal. Now time says in 2016, and we started at 1999. So we need to know how many years have passed since 1999. Let's use that. Y is going to equal 300, 1 plus 0.07 to the 7th power. Calculator says approximately $481.73.